Hello, everybody, and welcome to another episode of Me Programming Daily. Today on the agenda, drakon renderer again. And as I promised during the last session, today I'll try to work on this issue with primitive diagram 1. So I'm fully expecting some complications today as we've only been testing very simple diagrams so far with the new algorithm of balancing potentially unbalanced drakon graphs. So for example, it's pretty easy to balance. You only have two paths. The most complicated example that I've implemented so far is simple diagram 3, which has, if you can see it, it has 3 paths, 1, 2, and 3. Today we'll be experimenting with this diagram, which is primitive diagram 1. Let's try to find it in my files. It is going to render to something like this. So if you can see it, so you know what, let's switch a theme to something lighter. Maybe this one. So the diagram will be something like this. So now, I'm not sure what's going to happen when we use this, but let's try. What I'm expecting to see is that as we're producing DC paths, meaning all the paths from a divergence point to a convergence point, we will probably get stuck in a loop here, but that is to be determined. So first of all, let's copy this name and let's modify the run script. In the run script right now, we have the simple diagram 3. I've already prepared my branch. And let's see. Let's switch the theme back to the dark theme. And yet, we have 2 paths. And, okay, let's try to interpret these results. I think I'll have to close all this. If we interpret these results, well, really, do we need valence points here? I don't think we necessarily do, because this is not branching out, and this is branching out, and it only has 2 children, 1 and 2. So you know what, maybe I was overly cautious about this issue. Let's see what it generates. We have, let's see if we can arrange them in a slightly more readable fashion. So path 1 is workout, warm up, tired, end. Workout, warm up, tired, end. So this is path 1. And path 2 is workout, warm up, tired, lift weight, and That's it. But this is interesting because it does link us to lift the weight, but it doesn't go any further. 5 definitely has a dependent. Okay, so we didn't really have to do anything here. And it is sort of correct. But that coincidentally is not filling me with confidence. Quite the opposite. It is worrying me. Okay, let's go back to the issue we started here. Let's come up with something. Sorry, this will have to be edited. This doesn't even require a PR. But let's try to make this a little bit more complex. And before we loop back to tired from lift the weight, let's add one more action here underneath lift the weight. And let's see what we get. So instead of going back to 3, I'm going to insert an action. Let's call it action 6. Very creative. So this now goes to 6. And action 6 then goes to 3. Let's see. No infinite recursion. Again, the layout produced is correct. Now, I don't believe we still need valent points. But would be curious to see this. Okay, this is exactly what I needed to see. This is why I was suspicious. So we get a problem, right? we can clearly see that there are two paths, 1 and 2, but in the balanced paths, we only get one path. Let's just take a quick look to see which one it is. Workout, warm up, tired, end, and then action 6. This is completely incorrect. Okay, so we have these paths mixed up a little bit. So what I feared would happen, namely infinite recursion, did not happen, which worried me. But what did happen is some weirdness. I'm expecting two paths, but I'm getting one path. Let's try to debug this. But before we do, let's open a new issue. Nope. Oh no, I did something silly. Okay. All right, so I'll be working on this now. Okay, so as we dive into the issue, let me change the theme back to something dark. And I believe the problem is going to be in DC paths, but just in case, Oh, there's nothing really before that. We're listing all the icons. So let's just double check if I have the input right. 5 connects to 6. 6 connects to 3. This does look correct. This file is also looking correct. So what we'll need is the result from DC paths. Oh, sorry, paths. Oh, this is also incorrect. Oh. And this is why. Okay, that was... I believe what this this function needs, DC paths, is a convergence icon. And we just used to have the convergence icon last. But it's no longer last. Let's see, simple diagram 2. End is last. End is last. Simple diagram. End is last. Okay. All right. So. Before we even do this, we need to create a new issue. The way I select the end icon is incorrect. And this needs to be addressed. And this is also incorrect. So I think to take things gently and slowly, let's today focus on implementing 2 functions. One, which will get a title icon from a list of icons, and another one that will take or that will produce an end icon from a list of icons, so that it can be used in DC paths. And then I believe we can expect some recursion problems. and we're going to use them here. Now, before we do that, what I feel would be reasonable is to go to our existing issues and check validation ideas. There can only be one title icon, so I believe we're already checking for it. There can only be one end icon, and I believe we are already checking for it. That's good. So the validation, if I remember correctly, is here. The main module, one end icon present. So the function we'll need is something like this. We already have something like this for the icon, the title icon. Is it used anywhere? I don't think so. Here, at least. A title icon. Yeah. We do use this already, so we already have this. Let's create a very similar version of it just for the end icon. Oh, and we need a new branch. I'll probably have to do something clever with chaining title icon and icon dependent logic together using a slightly more intelligent syntax. Because at the end of the day, let's not forget that maybe is a monad. So maybe we can leverage some of its features in handling issues like title icon missing and icon missing. But for now, let's just leave it as it is. This is not the most elegant way of doing things, but for now, I just want to test DC paths. I would have to think how to do it in a cleaner way, but for now, it's not the most important thing. So here we have title icon and end icon. So now let's get back to our run script. Oh no, this is already a primitive diagram. And now, since the end icon is not last, let's see what it produces. And it is stuck in a recursion loop. Okay. That's good. That's what we wanted. And I think we'll draw the line for today. But before we close this session for today, let's go back to a simpler diagram. Yeah, that runs fine. Let's just make sure the file does get produced. It does. We have 3 paths, or at least we should have 3 paths. 1, 2, 3. Perfect. This is good. Okay. So we do have this. But let's not declare the issue finished yet. I'll want to do some research and think a little bit how to simplify this syntax so we don't have so many nested if-else statements or case-off statements. But for now, I think this is good enough. Get title, get end. Now I'm coincidentally not worried, even though we have this crippling issue with infinite recursion in DC paths. But this is actually what I expected from the beginning. Right, I think I'm going to wrap up the session today. It's going to be a short one. And during the next session, we'll probably try to tackle the problem of making this syntax look a little bit more presentable, and also to finally approach the DC paths function that loops indefinitely or calls itself indefinitely. Having said that, I wish you all a fantastic Thursday, and since today is November 28th, happy Thanksgiving to whoever celebrates Thanksgiving. And yeah, I'll see you next time. Bye.